Good morning, sir. My name is S. Ashok Kumar Reddy from CSC. My roll number is 234G1A0515. Today, my topic is implementation of queues using linked list with example. My topic outline of my topic is implementation of queues using linked list, NQ operation in linked list queue, DQ operation in linked list queue. Example of NQ and DQ operation. Time complexity analysis. Advantages and disadvantages of linked list queue. First, implementation of queue using linked list. A queue is a linear data structure that follows the first in, first out FIFO principle. Linked list is a dynamic data structure that consists of nodes where each node points to the next node in the sequence. Implementing a queue using a linked list allows for efficient insertion and deletion operations. First, we have to create a head. By next head is connection to the node. We have to create a node. Node have two parts. One is data and another part is address of the next node. Overview of linked list implementation. In a linked list implementation of queue, two pointers, front and rear, are used to keep track of the first and last elements of the queue, respectively. The front pointer points to the front of the queue, where the rear pointer points to the last element of the queue. Initially, both front and rear pointer points to null when the queue is empty. First, we have to create the head and create a node. We have to insert the elements one by one. First, we have to insert 10. Next, we have to insert 20, and we have to insert 30. By dequeuing the element, we have to remove the element 30. NQ operation in linked list queue. To add an element to a queue, a new node is created and its data is set. If the queue is empty, both front and rear pointer point to the new node. If the queue is not empty, the rear pointer is updated to point to the new node, and the new node becomes the new rear. Queue using linked list. We have to perform the NQ operation. We insert the element 15 and after the 7. DQ operation in linked list queue. To remove an element from the queue, the front pointer is moved to the next node. The node pointed to by the front pointer is removed from the queue. If the queue becomes empty after dequeuing, both front and rear pointers are set to null. Queue using linked list. We have to remove the element 9 from the first of the queue. Example of enqueuing operation. Let's consider a queue with elements 10, 20 and 30 and front and rear pointer pointing to node 10. Enqueuing elements 40 involves creating a new node with data 40 and updating the rear pointer to point to the new node. The queue now contains element 10, 20, 30 and 40 with the rear pointer pointing to 40. First, we have to insert the element 10 of the index 1 and 3, 5, 9 and 17. We have to insert the element one by one. Last, we have to insert 40. We have to see in figure. Example of DQ operation. Using the same queue with elements 10, 20, 30 and 40 and front and rear pointer pointing to node 10 and 40 respectively. Dequeuing the elements 10 involves moving the front pointer to point to node 20. The queue now contains elements 20, 30 and 40 with the front pointer pointing to 20. Before and after. First, we have to insert 10, 15, 20, 30 and 40. We have to removing the element 40 by using the DQ operation. Time complexity analysis. Enqueuing operation in a linked list queue has a time complexity of big O of 1 as it involves adding a node at the rear. Dequeuing operations in a linked list queue also has a time complexity of big O of 1 as it involves removing a node from the front. Overall, the operations on a linked list queue are efficient and have constant time complexity. Advantages of linked list queue. Dynamic size. Linked list queue can grow or shrink dynamically based on the number of elements adding or removed. Efficient operations. NQ and DQ operations has a constant time complexity in a linked list queue. Simple implementation. Implementing a queue using a linked list is straightforward and easy to understand. Disadvantages of linked list queue. Extra memory overhead. Linked list nodes require additional memory to store pointers to the next node. Slower access time. Traveling a linked list to access elements may be slower compared to arrays in some cases. Lack of random access. Linked list queues do not support random access to elements like arrays. Conclusion of my topic is implementing a queue using a linked list provides a flexible and efficient data structure for managing elements in FIFO manner. The use of pointers in linked list queue operations enables constant time complexity for enqueuing and dequeuing operations. Understanding the implementing of a queue using a linked list is essential for efficient data management and algorithm design. Okay, sir, thank you.